How great is it to be back in person? I know. Woo! And big shout out to Chariot Solutions for putting this on every year. This is the 17th year, I think, of ETE, and I haven't been able to attend every single one, but I've been able to attend most, and they've always been amazing events, and I'm just super happy to be back. So real quickly, just to give some more context of what Matt was saying, and thank you, Matt. I've had a fairly long career at this point, working as a programmer, working as an engineer in the enterprise. And I've gotten to do some really cool things. But frankly, I thought I was a pretty good engineer for the first 15 years of it. I thought I knew what I was doing. And then Scala happened. And I came to the realization really quickly that I had no idea what I was doing programming. I was really more of a Spring developer. I was somebody who built using frameworks and tools and much less about leveraging language concepts. So when I started doing Scala and I started seeing all of this type theory and pattern matching and functional programming and stuff like that, my mind exploded. And I just got really into it here in Philadelphia. And at that time, we started having meetups and people were getting together and talking about these cool new features. And I, became part of that community and eventually got to go work for the company that made Scala as an open source company. I did that for 5 years, and then, frankly, it's really hard to sell free things. So I left and then decided to go to Starbucks, where I built the rewards and mobile order and pay systems with Scala and Akka. They, to this day, continue to be built with Scala and Akka, as well as other languages. I did that for a little while and then went to Facebook. And I left the programming world almost entirely to go into site reliability engineering, because I felt like I really didn't understand what it was like to run systems at scale, like real scale. And so I stupidly went into the deepest part of the company, core systems, and worked in the Tupperware, containerization, orchestration, data shard management platform. And, just kind of melted down after a while. But then I left and I went to EPAM. Now, how many people have heard of EPAM? Wow, that's actually really good. Believe it or not, this is a Philly company based in Newtown. We are 60,000 people, about 55,000 of which are engineers. And we are also a $5 billion company. We're in the S&P 500, and we have no marketing presence to speak of whatsoever. We don't sponsor golf tournaments, is what I joke. 85% of our business is in referrals. So if you haven't heard of EPAM, it's okay, right? We're largely an offshoring firm. And very much like Chariot Solutions, just at scale, leveraging people from other countries and giving them opportunities to come to the US. So I am the chief technologist for AWS and site reliability engineering there. I've been there about 3.5 years. I live in Seattle, and it's great to see you all here. Now, before I get into this, I just want to point out that I'm not really good at making future calls. I've made some pretty decent ones, right? I knew early in my career that I wanted to do custom software development. And I didn't want to be one of those programmers who were doing SAP, ABAP, PeopleSoft. In the 90s, everybody was implementing all of these packages. I didn't want to do that. So I always kept my, career focused towards software engineering. And then when the timing of the programming languages hit, I just found I had a passion for it. And I dove into a space that I didn't know was going to have any kind of implications for me in my career, but it just excited me so much. And then I also kind of timed the death of programming languages in the enterprise. And not because I saw it coming, just because I saw platforms and I saw something I really wanted to understand more deeply. And so I went there. I've also made some bad calls, like I didn't invest in Bitcoin early. And as Al Icavella will tell you here, I bought shares of Tesla whenever it IPO'd and stupidly sold it like within a day because it fell from 25 to 21 and lost out on what could have been a very nice windfall. So not a great prognosticator. But what I want to point out here is be kind to yourselves. And you're going to say, why is he saying this? It's going to come back later in my talk. Nobody gets this exactly right. And trust your intuition. When you feel something around you, make a choice based upon where your passion lies, right? And I think that that's led me pretty well in my career. I hope it does for you as well. But this kind of defines our humanity, right? Anyway, So let's look back in 1994 whenever I started out. And back then, you had a lot of those legacy systems that were COBOL-based. They were mainframes or WANGs or VAXs, stuff like that. People were writing software using COBOL and RPG. You had the packaged software implementations for SAP and ABAP. And some people were running Unix-based systems, so you might get to do some C. Microsoft C++ was starting to become a thing because people wanted to program now for Windows-based boxes. And Visual Basic was a much easier way to do that than MSVC++, if anybody remembers, especially if you were just trying to wire up a prototype of what software would look like. Because what had changed at that moment was now you didn't have to write the front end using the back end system, right? Now you were able to write the front end completely detached as like a headless kind, not headless, a detached application that had no bearing on how it was written on the backside. And that was compelling, right? Think about where we were before. We were using dumb terminals and sitting there typing into something that was always connected to a mainframe. And now you could sit there and write something and have it connect back and be able to get database, queries done on a completely different machine. That had never happened before, and it was transformative. So we were able to, layer in lots of business logic using PLSQL and triggers and remote stored procedures that everybody is paying the price for today, trying to get off of these legacy databases. But that's sort of where we were. And there were programming language research taking place, right? Lisps existed, obviously. Smalltalk was out there for anybody who was really getting into the object-oriented world. Ada was a language that had been around for a while. But the enterprise, you weren't allowed to use them, right? They weren't options for you. And nobody had the ability to walk into their boss and say, I want to use this programming language. So you just did what you were kind of told. You were hired in. You learned that platform. You read a lot of books. That's the only way you were going to figure this stuff out. Maybe somebody sent you to a training class. But for the most part, you were in the bookstore and you were actually trying to figure this out on your own. So that wasn't a great way to live. In 2000, though, we'd already had the dot-com boom peaking, right? And that meant e-commerce. That meant, hey, people were trying to buy things online. And we didn't have a really great way to express that until the late 90s, right? There was Corba. Has anybody ever used Corba? Oh, some poor, painful people who've suffered that fight. Corba was this really great idea of how distributed systems could be built. And believe it or not, it still influences so much of the way people envision interoperability, right? And state management. But it was super hard to use, really complex, and frankly, I don't know a lot of people who were super successful with Corba. But what we did see was Java's emergence, and suddenly the idea that I could write one time and run anywhere was transformative. Right now we had the ability to say, for the first time, I can write something on the back end and use the same language to write it on the front end. Now, it wasn't great because if anybody who actually did this in Java using things like grid bag layout can attest, it was super painful to figure out how to do that because it had no bindings to the actual machine that it was going to run on, right? And so it had to sort of abstract over everything, and that was hard. For Microsoft, there was actually a better experience using C++ and Visual Basic with COM and DCOM and Microsoft Transaction Server. But typically those companies that were using it were bound to the Microsoft way, right? And I was typically working much more on the Java side. C# had started to emerge. JavaScript had come out, but they were young and immature. And frankly, JavaScript was scary for a lot of us because if anybody prefers having assurance that a language is going to run well, JavaScript was not that. But PHP was also available, and that was driving a lot of the simpler e-commerce and web experiences that you had. And we had all kinds of dodgy ways to glue this together, like CGI. But, it worked. You were able to do this. The problem was you could never quite scale. You could never scale your application horizontally. And J2EE, promised this idea of, anybody remember stateful session beans and entity beans? Who actually used them? Did anybody? 1, 2, 3 people? 4. All right. Well, 5. Good for you. I hope it worked out. I know that I went through multiple EJB server vendors like Persistence, gemstone beyond, the WebSphere and the WebLogics and stuff. And first of all, they were never quite compliant to the J2EE standard, but you ended up writing stateless session beans. And what that meant was you had a connection that you were, sending a request back to, and you were, going to then persist from there. You weren't holding on to state within the server. And that just meant that if that host went down, the request had to be sent again. It was actually a really big learning experience for a lot of us who were going to later build reactive systems. That is, just like whenever you're ordering food, a great way to scale. Resend the request whenever it doesn't respond quick enough. So, the thundering herd was also really difficult to deal with, right? We didn't have the ability to scale because you had a fixed set of machines that you were running with, and maybe the company would sit there and splurge because they had to deal with an e-commerce event coming like the day after, Thanksgiving or something like that. But you then were paying for all these machines that you weren't going to use the rest of the year. And so nobody wanted to do that, and it was just not fun. So we relied on, other ways to do this as much as we could. Glue, tape, duct tape, all that kind of fun stuff. But then by 2010, things have really, really changed. And for me, I think that this was driven by the right-hand side of the slide here. All of a sudden, social connection became a really big deal. GitHub was suddenly there, and we could share code, right? Before that, I think we had SourceForge, and some people did use it, but let's face it, SVN wasn't quite as good of a tool as Git was, and GitHub allowed you to take GitHub merging and stuff like that and be able to do it more effectively, leveraging an online tool and sharing of code. But more importantly, we found community. And I remember, using Twitter here in Philly, I could search using #Scala for other people around the world all of a sudden who were also interested in this language. And Stack Overflow is suddenly around, so now I can copy really bad code into mine. So, but you could ask questions, you could have dialogue. And meetups were starting, as I was saying before, where, people were passionate about this, were getting excited and having their own, groups and working on projects and showing them off, saying, hey, here's what I'm doing. Are you interested in doing this too? And I can't tell you how transformative this was. Literally, think about where we were 10 years before. If I wanted to understand XML, I had to go find a book. And you had to wait until a book came out. And by the time the book came out, it was probably obsolete anyway, because the next version of whatever tool, like servlets or something like that, was already out. But you were still just trying to learn. And now you could do that with a group of people in a much more, community-driven way, right? And so I think that really transformed everything. All of a sudden, look at the explosion of languages. You saw Ruby on Rails really, I'd say, be at the forefront of this, right? People who wanted to create new companies, new applications, new servers, suddenly had this ability to build something quick, easy, fast, get it out there, see if anybody likes this, right? Python, Groovy, Julia, Dart, Elm, there were a bunch of languages suddenly hitting us all from all different angles. And they all had their own specializations, right? I'm kind of lumping the first group together on, front end, but that isn't necessarily true because you could see that, a lot of languages became multi-use, right? And then you had sort of the back-end service-driven kind of languages like Clojure, F#, which was Microsoft's take on OCaml, with a lot of really cool functional extensions, and Scala. And then there was Erlang, which had been around for quite some time, right? And the Beam runtime was just amazing for building resilient systems. Like the theoretical uptime of an Erlang application, when written properly, was 9 nines, which is, 3 minutes in 100 years or something like that. It was pretty mind-boggling. But the semantics of it and trying to get your company to buy into using Erlang was always a little tricky. And that's sort of where you saw Scala's adoption coming from, because actors were incorporated into the language like just about everything else. And people were able to do this with the JVM, right? And then there were all the JavaScript variants. Look at CoffeeScript and TypeScript and ClojureScript, and they were just amazing, right? If you wanted to write JavaScript and actually have assurance it would run well, you could do that, right? But this didn't stay. Look at the great frameworks that came out of this, like Rails, obviously, Apache Storm, built with Clojure, was one of the early ways to sort of build together applications that were distributed and be able to share information. Akka, Spark, Node.js, right? Suddenly we had all these really powerful ways to express server-based software. And I'm not even getting into all the front-end JavaScript frameworks that exist, and there were a ton. So what's happening now is Java and C# are becoming legacy. Nobody wants to do it. You say, oh, I'm going to hire you for a Java job, and most of us are sitting there and going, but I really want to do something else. Like, people were super passionate about Clojure. They wanted to write Lisp on the JVM. And unfortunately for them, it was up to whether or not their company would let them. So 2016, this is about the time whenever I left the company that made Scala. And we saw Go come and become very prevalent through Docker and infrastructure, and the whole DevOps movement, right, was driving Go adoption. And plus, it was super easy to learn. You could be up and running with the language very fast, which I can't say is true for a lot of the other languages that I mentioned before. Rust has started to emerge. Kotlin, interesting thing about Kotlin, JetBrains created this language, right? And when they were doing it, they had this amazing list of language features that they announced on Twitter and did a blog post and everything. Everybody's like, that's awesome, but it looks super hard, And I was working at that company making Scala, and just to give you a sense of how language creators think, they're not in competition with each other. They are more focused on language growth, like how programming language theory will evolve. And so Martin Odersky, the creator of Scala, who created generics in Java, if anybody remembers the addition of generics, so you were assured of what was inside of a collection or something like that, he sat down, the Kotlin team came in from Russia and sat at the EPFL in Switzerland and worked with Martin Odersky on things that he'd learned trying to build a JVM-based language. And I just thought that was the coolest thing. So now, language birthing, if you will, language creation has slowed. And I'm thinking to myself, what's going on? And why is Scala not really, why does it feel like it's peaked? And where's Clojure, right? Suddenly, the Clojure team is talking about Datomic and the database that they're creating. And what does that have to do with, all the great ideas Rich Hickey had about building software better? And I wasn't entirely sure what was going on. What I came to realize was that no major services firms like the Accentures, the Deloittes, were proficient with these languages. And so enterprise adoption was somewhat stunted. If you had an organization that was very forward-thinking, maybe they saw value in attracting people and using these new languages, but generally speaking, a lot of them weren't. They saw it as a risk. And so they just wanted to stay with doing Java or C# or what have you. But then there were other problems. Working for TypeSafe in the open source world, we were beholden to VCs. And the venture capitalists would say to us that, hey, we're going to invest in your company, but we don't want you to be a services firm. We want you to be a product company, because the multiples for a product company are on the order of 10x, but the multiples for a service company are like 1.5. And I'm thinking to myself, because I was the head of consulting and training for TypeSafe, this is kind of backwards thinking, because if we don't have services to help people adopt these languages, then they're not going to be enabled, right? If we don't have services at scale, think about Red Hat and Linux. If Red Hat had been told, do not do services, where would Linux be today? And I think Linux would still be a really powerful thing, don't get me wrong. And I also think Linux was a big part of what happened in 2010, because now people were able to run on a platform that was agnostic to whatever kind of language or implementation you wanted. And yet, for a lot of these companies, this is why Cognitect decided to create Datomic. I'm guessing, right? I wasn't in the room with them whenever they made these decisions, but you had to have a product. And so we're sitting there at the Scala company, TypeSafe, and trying to figure out how we're going to build a product. And we're a language company. What do we do? And frankly, managed services haven't emerged yet. That's what was really interesting about 2016. They were starting to, but everybody was really sketchy about that.
Am I really going to let some cloud provider run this for me? No, they're just providing the infrastructure. That was the mindset that we had. And I can say that at Starbucks, when we were building out rewards and mobile order and pay, we were doing that running our own Kubernetes. We were running our own Kafka, running our own Vault, right? Cassandra, on a platform that we built over AWS. And that was just the reality we faced. We were like, what else are we going to do? If we want to do these things, we've got to stand it up ourselves using our CloudFormation service group. And that led to a lot of difficulty in understanding whose fault is it when something goes wrong, right? It's the beginning of platform. Nonetheless, what I'm seeing at this point is languages are becoming less prevalent, and the reason to me is the cloud and platforms, right? Look at today. There is very little new language coming out. And apologies to Richard Feldman, who's here, and talking about rock. There you are. Yeah, I'm excited about what you're doing. Thank you. You know, but at the same time, where's everybody else, right? And what happened? So Scala and Clojure really influenced Java, right? Look at where Java is today. All of the features, not all, a lot of the features that you see in Java today, they come from where these languages innovated, right, and brought them a path. But frankly, we're kind of at a dead place as far as languages go, and that makes me sad. So, you know, did they stop? Did people stop doing research on this? And I'd say no. The research is still happening, right? This is happening around formal semantics, type theory, effect tracking. Effect tracking is one of the things I'm super excited about, the idea that you can't have side effects. The compiler is going to see that before you put it out into production and tell you, hey, you have a side effect here. You've got a problem. And by that I mean something happening that you aren't aware or is going to be sort of a knock-on effect, right, whenever you make a call or a transaction or you do something. So when we see this in the compilers, it'll be super exciting. I don't know when Java is going to adopt it, but first I'm sure Scala will. But nonetheless, I mean, you see this in Haskell. Haskell's had effect tracking for some time. So we'll see what happens here, but I think the cloud in platforms have really diminished the importance of language. And this is because of the value companies see from leveraging the cloud. Right? Think about what the cloud is doing for us. All of a sudden, I don't have to stand up hosts anywhere. I can just spin up a couple on a cloud provider, and suddenly I can have a footprint anywhere in the world, and I can leverage their services to innovate faster than if I build it myself, right? And yeah, that kind of limits you because you're using something that, you know, they provided to you without any context to what it is you're trying to achieve. But it's still a lot faster, and maybe you can build around that, right? And that whole concept of cloud and platform became a lot more valuable to the enterprise than languages were. And that makes me sad, but at the same time, I get it, right? I see the power of this, and then I help customers do it all the time. So these platforms are killing languages, in my opinion, right? They're killing, in the enterprise, the adoption of languages. And that's just because of the prevalence of these platforms, and only so many languages can be supported. One of my big takeaways from Facebook was that working in the core systems platform, we could only support a finite number of languages well. And we had 3 of them at Facebook that were always going to be critical. C++, Hack, which is the typed version of PHP, and Python. Those 3 were going to get thrift bindings and all of the support from the way we wired applications together. Even Java wasn't a first-class citizen in 2018. And a lot of that had to do with the fact that the time it took to support the other 3 languages as a first-class citizen meant that there was no time to spend on Java, which is funny because Instagram is built on Java. So that was a really hard integration. Nonetheless, when this is going on, I see still posts that come from the blog at Facebook and stuff. And the engineering blog is fantastic, always was, talking about how now Rust is a first-class citizen at Facebook. And I'm like, Now, I'm not there, I don't know. But I have a hard time really believing that, right? It's not going to supplant Python. This is a company where they had, for their iOS app, no desire to adopt Swift because they wanted to keep everything in Objective-C because they'd had so much Objective-C code. Yes, there's interoperability, but then they've got to have engineers who know 2 languages, and they're saying, we don't want to do that, right? So this is a real driver to what happens. Think about now Amazon. If they're going to roll these services out, the language bindings they're going to provide are limited. And yes, you can do things through HTTP JSON and stuff like that, but at scale, everybody does RPC, right? And so, yeah, gRPC is fantastic. Facebook's probably not going to adopt that. They have Thrift, right? So that's the support they're going to provide to you. So, stable versus stagnant. And this is my shout out to Brian Getz. Brian is a frequent speaker at ETE, and he's not here to heckle me this year. But what is happening in Java as this language is evolving? We see that, from Java 1.2, when generics were rolled out, to 1.7, it was stability. There were new features, but for the most part, everybody was doing Spring Framework at that time, right? And doing dependency injection and inversion of control and all that kind of fun stuff, right? But I remember almost nobody adopting Java 1.7 because nobody cared about invoke dynamic, right? Because it wasn't relevant to them in the enterprise for what they're doing, building their applications with Spring. So, okay, post Java 8, we see lambdas come into the forefront, and we've seen them add a whole bunch of features like Jigsaw, which is the module program, right? Like OSGI kind of stuff. Valhalla, that's the value types, and you see Loom, which is green threads on the JVM, which will finally get rid of the idea that when you do a JDBC call to a database that it will be blocking. Right now you have non-blocking JDBC is the vision. I know, it's very exciting, isn't it? And yet, how many people are actually leveraging features like this in Java? Oh, first of all, how many Java developers are here? Okay, so a sizable number. How many of you are keeping up with the pace of this rollout? Now what, 1.19, 1.20 is already planned. You're actually up there using those versions. A lot of people aren't. I'm constantly going out and talking to customers who are like, yeah, we're actually still running 1.8, right? And they're even paying Oracle for support, even though Oracle says we don't support 1.8 anymore, right? It's pretty funny. Yeah, it's just the reality that Java is, right? It is Spring Boot world. Spring Boot took over the world. And it kind of, again, makes me sad, but at the same time, it's available to you. All of these really cool features. Pattern matching now in Java. Woo, right? I love that. Anyway. And I feel like a lot of programmers don't care. In the enterprise, don't get me wrong. I know that if you're here, you're probably a passionate engineer, and therefore you do care. But for a lot of the developers who are out there, they're just trying to build a Spring Boot app, and they just, don't care. Or if they do care, nobody's letting them express it. So, and I just want to call back to a moment here. Here at ETE, we used to have a languages track. We used to have, speakers at every single slot coming in and talking about programming languages. And now we have Richard. Thank you, Richard. Thank you for being the stalwart. But, yeah. But the lineup of people here, I just like Jim Wayrick, Rich Hickey, Heather Miller, David Nolan, Stuart Sierra, Jean Yang, who's out there doing her thing with Akita software now. Doug Lee came and spoke at ETE back in, I think, 2013. He was the creator of Malloc. We had Alan Kay 2 years ago, unfortunately virtual. But, I mean, the guy who came up with the idea of object-oriented. And now the tracks just simply don't include a lot of languages because there's not as much interest in it. So I feel like this is on us a little bit as developers, but also the enterprise is just not giving us the flexibility, allowing us to express how programming languages can help drive business value for them. So, big corporations own big languages. If a language is going to succeed today, it's got to have an Oracle, it's got to have a Microsoft behind it. And even then, look at Dart, look at F sharp, they haven't necessarily grown or progressed. They have feature-wise, but they haven't like grown in adoption or anything like that. And so, the big corporations really are the ones who control this. And if you don't have a big corporation behind your language, you're going to struggle. Scala tried to address this. We have the Scala Center in Switzerland, and the companies who are a part of the Scala Center, who fund the Scala Center and are at the table as the language evolves, include Morgan Stanley, Goldman Sachs, Verizon, right? These companies have made a commitment to the language, and yet Scala is still not growing, at least here in the US, right? So if small companies can't drive adoption, how are we going to get past this? So then the question becomes, how are languages going to be relevant again in this world of platforms? How are we going to make languages something that, are going to be part of a business value driven solution? And so now we're going to talk about AI. Because buzzwords, right? ChatGPT and everything. No. It started me thinking about, can we create artificial intelligence using the existing language constructs? And in my head, I'm thinking about how, as a brain, we are not computational engines. There are so many inputs, so many factors. There's emotions, right? There's judgment. And while there is sort of a concept of like maybe least recently used or maybe least relevant, cache eviction where we forget some things, right? There's a constancy to our consciousness that goes beyond loops, right? And so languages don't need to evolve in their current form. They need to completely change. So, has anybody ever heard of the Chinese room experiment? I'm actually a little surprised because I was thinking about this, trying to figure out where things are going, and I happened across John Searle, I'm sorry. And John was I think he's still alive, American philosopher who is in the computer science space. And what John was saying is that if I'm in a room and somebody hands me through like a slot in the door a card in Chinese, I can't read Chinese. John's saying he has no understanding of the Chinese language. But he can use methods to figure out what is on that card, and he can formulate an actual response. Okay, and then he can hand it out the door to somebody else. And he has completed the computational transaction, right? He's done the work. But now the person on the other side of the door has an expectation that John speaks Chinese. And he's like, and I don't, right? So I'm mocking the ability to be a Chinese speaker, reader, communicator, but I am not somebody who can do this. And he's saying that's, in essence, what computers are doing, and that is the fatal flaw of the Turing test. The Turing test can show that you can do the computation, but it doesn't mean that you understand the computation, right? So he had 4 axioms that he came out about this. And the first that, computer programs are formal semantics and have purely abstract notions. Think about it in terms of ones and zeros, right? There is no context to that. It is going to take those ones and zeros. It is going to perform a computation. It is going to output something. But it's going to have no broader context about it. Now, we can build neural nets, and we can build, cached data, and we can probabilistically say that something is the right answer. But we are not doing that because we have conscious thought. We're doing that because we are guessing with some level of certainty. So, thoughts and perceptions and understanding have mental content around them that drive the way that we think. And programming languages don't do that. Programming, as it's set up, I don't know if this is also a hardware problem, but the way that we are building our computational engines does not support actual artificial intelligence. So there's a distinction between these formal elements and those that have intrinsic content. John came up with several conclusions. I'm sorry, I actually have to read my slides to make sure I get this right. He concluded that programs are not suitable for minds, right? And it's not that a computer can't think in terms of performing an action to come to a conclusion, but it's not equivalent to the way that we do that is not equivalent to formal symbol manipulation, right? So languages need to change, to evolve, to support this if AI is truly going to progress. We look at what ChatGPT is doing. We put in answers, we have conversations with it, and we think this feels like a consciousness. And yet, it's still only responding based upon what it has learned from a data set and providing what it thinks is probably the right answer to you. And I love the joke that it's like mansplaining. But anything that's going to duplicate these behaviors, right, could not be done running a formal program, was John's assertion. And so, you know, how human brains produce these mental phenomena cannot be modeled. Mental phenomena being things like hunger, right, desire, emotion, anger, right? Where do these come from? How do we model that into a system that is going to actually be an intelligence, be a consciousness? And today's languages don't support that. So, if you want to read more, I highly recommend you look up this, it's like a 5-page almost magazine article from something called Is the Brain's Mind a Computer Program? And it talks about this in more depth. It certainly goes into the Chinese room experiment with more depth. But I highly recommend you check it out if you want to see more about this. And so how are languages going to evolve? And, you know, this is where I'm saying, remember kindness and stuff like that. Be kind to yourself. That's what makes us human. That's what makes us a consciousness. And languages, I don't know how this is going to happen. Sorry, I wish I did. Need to evolve to support that if AI is going to transform into an actual consciousness. And yes, with all the limitations that should exist around that, think about what that means for cognitive bias from a computer, right? Because that is a likelihood, because it would be a consciousness just like us. Where does kindness figure into that? Where does cruelty figure into that, right? It's not just a computer model. So, that was my talk. Any questions?